how to solve quadratics by graphing, how to solve quadratics by factoring, and then we talked yesterday about how to solve quadratics with the square root method. Okay, so now what we're going to look at is how to solve quadratics by completing the square. So this is actually it's going to be a process to get our equation in the form we were looking at yesterday, where we can just take the square root and do square root method. Okay, so we're going to take trinomials and do this process so that we can just then take the square root of both sides to solve like we were yesterday. So before we jump into the new process, if I take the square root of a number, what do I have to remember? What did we say yesterday? Don't forget what? Plus or minus. So when I ask for the square root of 9, it's not simply 3, it's 3 and negative 3. Okay, so it's going to be both of those. So what would the square root of 4 be? 2 and negative 2. Okay, so don't forget 2 solutions when we're taking the square root. Okay, we are going to use what is called completing the square to find roots. Okay, meaning we are going to create a perfect square trinomial that can be rewritten as a binomial squared. Okay, just a quick refresher. We've talked about this in a couple of the different notes. What's another name for roots? Solutions. What else? Zeros. Roots, solutions, zeros, they all mean what? If you're thinking about it graphically, those are your x-intercepts. Very good. Okay. All right. Now, part of the process of completing the square is having to do b divided by 2 squared. Okay, so we're just going to practice just this step in it. Okay, so we have this quadratic. Okay, the first thing we have to be able to do is identify what is b. What part of this equation is b? Just 6, okay? B is the coefficient of the x term. Okay, so remember, those of you who didn't shout it out, ax squared plus bx plus c. X and x squared are not part of a and b. Okay, they're the variables. The a is the coefficient of x squared, b is the coefficient of of x, and then c is your constant. Okay, so our b in this case is just 6. So it's whatever is right here, that is your b value. So in this case, 6. So when we do b divided by 2 squared, we're going to divide that. Notice the parentheses. The parentheses are important when you end up having to deal with a negative b value. Okay, if you don't have those parentheses, you'll end up with the wrong sign. Okay, what is 6 divided by 2? So this is 3 squared, which is just 9, right? Is everybody good with doing b divided by 2 squared? Okay, we'll see in just a minute where that comes into play, why we have to be able to do that. Okay, now, again, when I say the parentheses are important, this b was positive. So the parentheses weren't important, but always get in the habit of using the parentheses, because had your b been negative, if it was -6 and you wrote -3 squared without the parentheses, you would have gotten -9 here, and that's wrong. It's +9. this number that you get when you do b divided by 2 squared should always be positive. You'll understand that? Because you are squaring a term, should always come out positive. Any questions so far? All right, so here are the steps we're going to follow for the completing the square process to solving quadratics. Okay, we're going to set our function in standard form equal to 0. Okay, we're going to divide out any GCF that we see. We're going to move our constant to the right side. What part of that equation in standard form is the constant? When it says move the constant to the other side, what part of this equation, ax squared plus bx plus c, is the constant? The c. That's going to get moved to the other side. We're just going to have x's, the x squared and the x term together on one side and the constant on the other side. Okay. Then we are going to identify b. Okay, and we're going to do half of b and square that number. That's that b divided by 2 squared. Okay, that's what that step is. B divided by 2 squared. Then whatever number we get there, we're going to add that number to both sides of the equation. So what that's going to look like is we're going to have our we're going to have our x squared plus bx plus blank equals, and then our c will have been moved to the other side by opposite operation, and we're going to add that same number to the other side. Whatever number we come up with here, this whole value that we get, that's what's going to plug in here. So far, so good? Then we are going to rewrite the trinomial. So when it says the trinomial, it's talking about this right here. This is now a trinomial. We're going to rewrite that as a binomial squared. What's the difference in a trinomial and a binomial? 2 or 3 terms. Trinomial has 3 terms, x squared, x, and constant. Okay, a binomial is just 2 terms, and we're writing it as a binomial squared. So we're going to have parentheses squared. And in these parentheses is going to be a binomial. Okay, and it should be x. And then it's going to be whatever sign here. It's going to be a plus or a minus. That sign is going to match, purple here, whatever the sign of b is. So if it was a plus, it'll be a plus in the binomial. If it was a minus, it'll be a minus in the binomial. It's going to match whatever that sign is. Okay, and then what comes here to create your binomial squared is whatever you got when you took half of b. Whatever you got up here. What color have I not used? Green. So this b divided by 2, before we squared it, that's what's going to go here. And it's going to equal this number over here. This, you combine this, you simplify whatever this number was plus what you added. Okay, and you get a new term there. Then we're ready for taking the square root of both sides. This is like what we did in yesterday's notes, where we isolated the square term because now we've got this binomial squared by itself, and we're ready to take the square root of both sides to solve for x. Okay, so we take it back to what we were doing yesterday. All right, so it might sound a little confusing with just letters and blanks here, but now we're actually going to put it in to an example. We're going to actually try one here. Okay, so first thing, we want standard form set equal to 0. Luckily, this is all in standard form already. You just replace f of x with 0. Okay, step 2 says take out a GCF if there is one. Is there a GCF here? No, so no step 2 here. Okay, now if you want to be writing the steps down as we go, I set it equal to 0. Check for a GCF. This one, there was no GCF. Okay, so then step 3 is to what? What's the next step after I check for a GCF? Move the constant to the other side. So in this case, it's minus 27. How's that going to get moved? What's the opposite of minus 27? So I'm going to add 27 to both sides to move it. Okay, I'll try and color code this for you. So we moved C. That's what we're doing here. Okay, so next then is identify B and do the B divided by 2 squared. Okay, so this is 27 equals x squared plus 6x. This is where I'm at so far. I'm going to do B divided by 2 squared. Okay, what is my B? What's the B value here? 6. Okay, so I'm going to come over to the side here. I'm going to do B divided by 2 squared is 6 divided by 2. I know I did this up here in that earlier example, but I'm still just going to show my work for the sake of your notes. I get 9. Okay, so B, I plugged in and I got 9. That's what is going to be added to both sides. Okay. So far, so good? Trying to keep it labeled and color-coded for you for the process. Once you add that to both sides, we are now going to rewrite the trinomial as a binomial squared. Okay, so this is where I'm going to change this to binomial squared. That's going to be x. The sign stays the same as the sign of B. So since that was a plus, this is a plus. Now, what did we say goes here? What did I write there? B divided by 2. What was my B divided by 2 in this problem? Yeah. That's what's going to go there. So I rewrite as binomial squared. I'll highlight here the sign. Why I used a plus was because this was a plus. Okay, what about on the left side here? What's 27 plus 9? 36. Okay. That is the completing the square process. I am done completing the square. I took a trinomial and I created a perfect square binomial. I went from standard form to what is called vertex form, which we'll get into a little later when we are doing more with quadratics. Right now, we are just focusing on finding the solutions or the x-intercepts. Okay, but being able to change this from standard form to vertex form, that's the whole point of completing the square. Now, what I am supposed to find in this particular problem are the roots, zeros, x-intercepts. So I want to solve for x. So now that I have it in this format where I have a binomial squared, I can do this last step, which is just take the square root to get rid of that square and finish solving for x. So that is the last step, is take the square root and solve for x. Now, when I take the square root, what did we say right at the beginning of these notes? Not to forget. When you're taking a square root, don't forget plus or minus. We talked about that yesterday. Now, 36 is a perfect square. What is it? Square root of 36 is 6. So we have positive or negative 6 equals, and then the square root canceled the square. So now this is just x plus 3. Am I done? Did I solve for x? What do I need to do to solve for x, to get x by itself? I need to subtract the 3 to the other side. Now here's where you have a personal preference comes into play. Do I want to just write minus 3? And in my head realize I need to do 6 minus 3 and negative 6 minus 3? Or is it my preference to actually write that out separately? Negative 6 equals x plus 3 and positive 6 equals x plus 3. And actually see it so I can see I'm doing negative 6 minus 3 and I'm also doing positive 6 minus 3. Again, that is up to you if you want to split it and show it separately like that. Or over here, just in your head, be like, well, negative 6 minus 3 would be negative 9, and 6 minus 3 would just be 3. So we get the same solutions, whether you write it just as a list or write it separately as x equals, right? So I'll put a little or there. Now, if you were wanting to check your solutions, we've talked about this. Anytime you solve for x and you're not sure if it's right, or you just want to check and be positive, you can always take these values that you got and plug them back into the original and see, does it actually work? Does it make it true? In this case, does it make this right side equal to 0? So you could plug in a 3 and check. You could plug in a negative 9 and check, and they check out. Also, if you had a graphing calculator, if I were to give you Desmos while you were doing this problem, how could you have done this in Desmos, or how could you check it in Desmos? What are these supposed to represent, these solutions? What happens at negative 9 and 3? What are those? The x-intercepts. If I were to graph this quadratic equation and look at the parabola, it would cross the x-axis at -9 and 3. So I could check this by plugging this in to Desmos and looking at the graph and see, does it actually cross at -9 and 3? Right? Y'all agree? Technically, if I had a calculator, I could just plug it in and see where it crosses and see that it's -9 and 3 and not have to actually do any work by hand if I were given the full function calculator the whole time, right? Don't understand that? Okay. Now, we do want to learn this process and know this process, and we're going to use this process again more later, okay? But for now, we're just using it to find the zeros. We can always check our zeros in the calculator because it's the x-intercepts. So where's that parabola across the x-axis? All right, so I'm going to go through it again. I'm not going to write these steps every single problem. I've got them written once. You can refer back to them like this, okay? I'll try and keep color coding, but I'm not going to just rewrite that every time, okay? All right, so this one is not set equal to 0. So I could move the x squared over to the right so that it is set equal to 0. But what would happen if I did that? If right now it's positive x squared, how would I move it to the right side? Anybody? If I want to move a term across an equation from one side to the other, how would I do that? I would have to subtract it because it's positive, so the opposite would be, it would become negative on the other side. I do not want to have to deal with a negative a value. It is much easier to work with a positive a value. It saves me a step, saves me some time. So rather than moving that x squared to the right, I'm going to move these other terms to the left. Everybody understand why I'm doing that? All right, so when I say move them to the left, I'm doing opposite operation. So this 8x will be added since it's being subtracted over here. And the 33 would be subtracted. Now, you're going to see in a second, some people are going to ask, why did I bother doing that? Because now I've got it set equal to 0, which was step 1. Step 2 is to take out any GCF. Do y'all see a GCF? Anybody see a GCF? No, there is no GCF. Okay, so then step 3 is to move C to the other side. Well, heck, I just moved C to that side. Why did I bother doing that? And it was to check and make sure there's not a GCF. Now, if you in your head can visualize that and you can see ahead, you can see, well, A is an understood 1. There is not going to be a GCF. Then you don't have to bother having moved C in the first place, and you could have just left it over there as 33. Okay, so I'm going to put that C back over there. On the right side is positive 33. So far, so good? All right, now I'm ready to do the B divided by 2 squared to figure out what I'm adding to both sides. So what is my B value this time? I need to identify B. 8. It's the coefficient in front of X. Okay, so we're going to do 8 divided by 2 squared. So that's 4 squared, which is 16. So that's what gets added to both sides. What color did I use for that? Blue. All right, now I'm going to create a binomial squared from this perfect square trinomial. I'm going to keep the sign of b, which in this case is a plus. And what is the number that I'm going to add here? Yeah, it's the half of b that we did over here. That's what's going to go here. And I kept it as a plus because that was a plus. So that is 4. What about when I simplify on the right side? 33 and 16, what does that give me? Very good, thank you. All right, so I am done completing the square. Now I'm ready to solve for x. Here, let me double check I got all my highlighting. I'll put the yellow there for moving C. Put it back over there. Okay. All right. Ready to take the square root of both sides? Don't forget your plus or minus. So that's going to leave me with x plus 4 equals positive or negative what? Is 49 a perfect square? It is. The square root of 49 is 7. So positive or negative 7. So again, I'm going to have to subtract this over, and I can either, in my head, understand that that means I'm doing 7 minus 4 and negative 7. So I'm going to get 2 answers, or you can split it and write it separately if that's easier for you. So I like to keep mine in numerical order, left to right. So I'm going to do the negative 7 minus 4 first, which would be negative 11. And the positive 7 minus 4 would be 3. So those are my solutions, or my x-intercepts. That's where my parabola, if I were to go and look at the graph of this, that is where it would cross the x-axis. Now, if you want to do this by graphing, you do need it set equal to 0. So you would have to have still done this first step of moving the 8x over and moving the 33 over. This piece right there is what you would type in the calculator to see the graph. It does need to be all on one side, equal to 0. Good. All right, let's do one more together. We've got x squared plus 16x equals 9. Now, what I said at the beginning of the last problem is, yes, I could move this c over to get this set equal to 0 and then check for a GCF, but I can see right away my a is a 1, so there's not going to be anything to factor out. There's no GCF. So I'm fine with how it is. I don't need to move the c over to get it set equal to 0 just to move the c back over. Does everybody understand that? So we're good with how it is. The c is already on the other side. So I am ready to figure out what is going to be added to both sides to complete my square. And I do that with b divided by 2 squared. What is b? What is our b value here? 16. So 16 divided by 2 squared is 8 squared, so that's 64. So 64 is what gets added to both sides. Now I'm ready to write the trinomial as a binomial squared. So it keeps the sign, so a plus. And what goes here in this blank? B divided by 2, the 8. Over here, 9 and 64, what is that going to give me? $73. So now I am ready. Let me go ahead and highlight that I kept this sign. Oops. Now I am ready to take the square root of both sides to solve for x. So I've got x plus 8 equals plus or minus the square root of 73. Notice I left that one as a radical, as a square root, because 73 is not a perfect square, is it? It's not. Can it be reduced? Remember, when you have a radical, you could try to make a factor tree and reduce it and take some factors out from under the radical. But in this case, 73 is a prime number. There's no factors of 73 other than 1 and 73. So there's no simplifying it. It's going to stay square root of 73. Now, what do I still have to do to solve for x? X is not alone yet. I need to move that 8. Opposite operation is going to be to subtract 8. Now, am I going to do 73 minus 8? Y'all think? I am not. Why? Are those like terms? 73 is under a radical, isn't it? Under a square root. Is the 8? The 8 is not. So we do not combine these. We cannot do 73 minus 8. These have to stay separate. Okay, this is under a radical, this is not. Okay, so we are not combining these. So I'm going to write this as negative 8 plus or minus the square root of 73. Those are my solutions. Now these are real. There's not a negative under the radical, is there? So this is a real number. This actually does cross the x-axis. It's just an irrational number. Okay, it's going to be some decimal value. Okay, and that's fine. I can just leave it written like this. I don't need to come up with the decimal. Everybody okay with that? All right, so I want y'all to try this last one. It says you try, or try. Okay, I'm going to give y'all about 2 minutes to try it. If you're watching this as a video, just pause your video real quick. Give it a shot and then unpause when you're done. Those of you in class, I'm going to freeze the screen and give y'all 2 minutes. Then we will go over it. All right, let's go ahead and take a look at this and see how far you got. So the first thing I did was move the 4x to the other side by subtracting, so it came minus 4x. I left the constant on the right because I knew there was not going to be a GCF because there is no a value. So then I was ready to figure out what gets added to both sides by doing b divided by 2 squared. B was negative 4. This was the first one where the b was negative. So these parentheses really mattered on this one because negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. So you have to be careful that you have those the parentheses, because if you just wrote negative 2 squared and said that's negative 4, you're wrong, because when the negative is squared, it comes out positive. So it should still be a plus 4 on both sides. Then when I went to go and create the binomial squared, it's a check that that should be the same sign. The number that goes here is half of b, which was negative 2. So that's why it's minus 2. And you can see it kept that sign. Okay, over here that combined to a positive 3. So I finished completing the square, then I was ready to take the square root of both sides. Don't forget your plus or minus. So I ended up with x minus 2 equals the positive or negative square root of 3. And then I have to add 2 to the other side. And again, the 3 is under the radical. It cannot be reduced and it cannot be combined with an integer. So those have to stay separate. So this format, I'm always going to write, if I have an integer and a radical term in my number, I'm always going to write them like this, with the integer first, and then my plus or minus, and then my radical. Just like I did on the last one, the integer first, and then plus or minus, and then my radical. How many of y'all got that one? Okay. All right. Now we're not going to do a new practice assignment over this quite yet. On Friday, I'm going to be out for a golf tournament, so I'm going to make that your practice day. And you'll have class time to practice this and the method we're going to look at tomorrow. But what I want to do with the rest of our class today is I want you to get your laptops out and we're going to look over yesterday's FA. So I'm going to stop this video and I'll create a second one going over the FA if you want to check that video.